It's a good day to you all. Yes, hope that I find you well. My name is Itai Chikaba, one of the group members that have been tasked to look at vulnerability analysis tools. So I have been tasked by the group to discuss or to share with you one, two. As you may be aware, there are several tools that can be used in vulnerability analysis. But for the sake of this presentation and its expectations, I'm going to look at only one and only one vulnerability tool. And one of the group members is also going to look at another tool. So shared on screens are the members that constitute group 7. And group 7 is the one that is going to be looking at that practical task displayed on the screens, vulnerability analysis tools. So I've selected to look at Wireshark. Wireshark is a vulnerability analysis tool. It is one of the most powerful tools that is being used to intercept the networks, several industries, several lines of business that consider or that value their network security or that cherish issues to do with data security and integrity are employing these vulnerability analysis tools. And Wireshark is one of the dominant tools that is being used across the globe. So I'm going to open my Wireshark. If you can see, the mouse is already pointed at the shortcut icon. I've already done the pre-installation before this presentation. So I'm going to open the application. So as the application is opening, men would probably want to know what Wireshark is all about. So Wireshark is often found in the security toolkit. Pen testers use it to point out what is happening with the network and to assess traffic for vulnerabilities in real time as they happen or as they attempt to knock onto your at the doors of your network. And by reviewing connection level information as well as the constituents of the data packets, Wireshark highlights their characteristics, origin, destination, and so forth. And when it flags potential weaknesses, a pen testing tool is still required to exploit them. So Wireshark is a network protocol analyzer that lets you see what's happening on the network in its finest detail. It is an open source project. There is no attached developer or inventor to that Wireshark. So you can actually get it on for free online. And it is compatible with very common operating systems like the Windows, Linux, Mac, and so forth. Wireshark's packet sniffing, network analysis, and protocol analysis capabilities make it very useful when assessing traffic vulnerabilities in real time. It can scrutinize connection level information as well as the various pieces that constitute the data packets. Common problem that our Wireshark can help troubleshoot include dropped packets, and malicious activities on the network. It lets you put your network traffic under a microscope and provides you an interface to filter and drill down into that traffic. So there we go. My Wireshark is finished populating, and this is the full view of how it looks like. I'm running on version 1.12.3. I'm sure some are already ahead of me in terms of version, probably some are a bit behind, but I think the concept still, both versions are going to satisfy the concept. So the interface list is already populated. So you can see these are my interfaces. The local area network, the local area connection, Wi-Fi, Bluetooth, Ethernet, yeah. So for the purpose of this presentation, I'm going to use the Wi-Fi connection as I'm connected to the Wi-Fi, so that I'll be able to analyze the packets in my particular network. If I choose another interface, we have the risk of not getting our goals because there won't be any flow of data packets. So let me choose my Wi-Fi there. There we go. So this is how it looks like, you know, funny flow of very diverse characters, funny numbers, and you name them. There's also several colors that are being displayed on my screen. Now I've also learned that you can change the animation, the background animation of those of your Wireshark, and put the colors that suit you. Okay. So as we can see, these are the headings of the Wireshark. But through our research as a group, I've noted that much emphasis is directed at picking the source of the packet, the destination of the packet, the protocol that is being used by that particular packet. So if you highlight a certain packet, beneath here, it will give you the details of that particular packet. Like here, to give you the Internet Protocol version, which is version 4. I'm running my Wireshark in a network that is composed of a few hosts. So it's not a very complex network. It's actually a small network, but I'm very sure that it will satisfy the aims of the presentation. So as you see, SRC here simply depicts the source of the packet, which happens to be 192.168.100.19. And the destination is 255.255.255.255. I would like to believe that this implies that it's a packet that has been broadcasted. So any host in that particular network can listen to that packet. it is also shown here that it's using the UDP protocol, which is the user datagram protocol. And the source port number is also given, and the destination port number is also given. And the checksum, remember in our first quiz, we also came across the issue to do with the checksum error. So here it simply tells us that the configuration that has been done by the network administrators, they have not validated, they have not enabled the checksum. So the greatest disadvantage of not validating the checksum means that data can be tampered around in between the source and the destination. And the destination or the end user is no way of picking that the data has been tampered with. Remember, that is the essence of checksum. Checksum is to do with data integrity. That data should, data originated from the source should arrive in the same format as it was originated. So if the checksum is not enabled, it proves to be difficult to the destination or to the end user to really tell if anything has been done during the course of transmitting that data. So that is also shown. So if you click on the IPv4 of packet number 1, underneath here you will see the digits and letters in blue being highlighted. This simply shows that the packet has been disintegrated into the hexadecimal format. Again, I think we also came across that in that first quiz, which many of us didn't do well. Yeah, so that is quite interesting. We can also take, for example, go to packet number 17. Packet number 17, it clearly shows us the source, which is 192.168.100.46, to destination 193.123.21.146. Clearly this shows that the destination is an external destination. It's not from, it's not going to be a destination within the same network. It's not in the same subnet. So the destination is an external one. There's also a CK in square brackets. I'd like to believe that it's the destination that is acknowledging, or that is acknowledged, the data packets in sequence, which means the data packets in sequence are 46, and the destination is acknowledged receiving the 46 packets, simply telling us that there was no data packets, there were no data packets, or there was no data lost during the course of transmission. This is also essential, probably. It can also, to one extent, or to a lesser extent, tell the network administrator or the network forensic person or data forensic person to tell if some packets have been dropped or some packets have been added during the course of the transmission. Say, for example, the sequence of data packets here tells us it's 46, then the acknowledged packets goes on to show us 49. Then clearly this doesn't make logic or doesn't make sense. So this can create a room for need to investigate what has really transpired. Was the data that has been originated and sent is no longer in the same format or same size or frame with the one that was sent. So these are the protocols where my mouse is hovering over. The RP simply tells us is the address resolution protocol, the TCP, the UDP, the user datagram protocol, and so forth. As I'm scrolling down, tells us there are no or very few machines using the HTTP protocol, right? Okay. So there's also a feature that is so exciting on our Wireshark. A feature where we can actually run simple commands, and if they are running good syntax, we have control over the flow of our traffic that is getting into our network. For example, here I can choose to say not so in that space of the filter. If you see that color, which is pinkish or rather reddish, whatever color you want to call it, it means the syntax is incomplete or the syntax has got an error in between. Because if the syntax is correct, it should this space should turn green. So let's try to complete the syntax. Not TCP. So, the Wireshark is already loaded with some libraries. So if you type the initial letters of a library, those libraries will pop up or will populate. Then you choose the library that you want to fetch. So you just double click that particular library and it goes on to place. Port is equal to what is the port number here? The port number is 443. Let's see. Okay. So it has turned green, implying that this particular syntax, this particular command is free from errors. Then you set a rule by apply. You can apply. So that command is simply prohibited that particular data packet from accessing our router or our router, whatever way we want to call it. So you see that I've already eliminated that that data packet, because it was the data packet 77. So if you can check the sequence of numbering, we have 74, 75, 76, 78, which means I've gotten rid of number 77, the data packet 77. Okay. there are other destinations that are defined as broadcast. I think if you have done a bit of reading, it simply tells us broadcast destination. It simply tells us that the message can only go to all the hosts in that particular network. So every host in that particular network will be listening to any data packets that are incoming. That is what it simply tells. We've also situations like many situations as I can pick from the Wireshark. Who is packet number 51? Who is 192.168.100.201? So the Wireshark is intercepted a certain data packet using the address resolution protocol, and it's raising a red flag to the administrator to check on that particular data packet, probably where it's coming from, its contents, if it's not meant to harm the network or it's not meant to harm the computer system. These are generally packets that are commonly picked by the Wireshark, but doesn't necessarily mean that they are harmful. But they always conscientize the administrator to have a look on such kind of packets. We can also have instances where a data packet, for example, number 112 here, it's coming from 192.168.100.248. Destination again, 192.168.46 using internet control messaging protocol, ICMP. The destination is, the port is unreachable. Remember when we did our theory part of port scanning. This is also, in some cases, the duty of the network administrators to configure even the firewalls for on certain ports, such that even if a data packet is looking for a certain port, if it's configured on the router not to be accessible, usually that is where we get this kind of messages that the port is unreachable. It's very important to protect our networks or our ports by making such configurations. It's one way of ensuring that during port scanning, vital ports cannot be reached. We can actually make these ports look like they are dormant or they are not available because of the configurations that we will have done on the firewall or the router. Okay. Yeah, so in short, this is what we have on Wireshark as a vulnerability analysis tool. Thank you so much.